and we're section 5.1, and definition of a function composition. Suppose f and g are two functions. The composite of f with g, and it's denoted by that open circle between the f and the g, is defined by the formula f of g of x. We can rewrite that where we have f and then we put g of x inside of parentheses. And then more often than not, you'll see me write it this way, where I have g of x inside of square brackets. And that is provided that x is in the domain of g. Well, it better be in the domain of g or we don't have a function. And that g of x is in the domain of f. So whatever happens inside here, it's got to be in this domain, and whatever happens inside here has to be in that domain. So we have two different ways of writing this, f of g of x, and it's read f of g of x. I rewrite it usually like this. And sometimes you'll hear some instructors say fog of x, or you might hear them call it, anybody here know, goth. So just be mindful that if you have a symbol with an open circle, that means we're talking composite function. Okay, so what does a composite function mean? Well, I've made up a little machine here, and my little machines are in boxes. So we have 36 inches, and that's my x. I'm putting that into my first machine. It's my f function machine. And my f function machine changes it from inches to feet. So when it comes out of the f function machine, it's in feet. So I've taken x, put it through the function machine, it came out as 3 feet. Then I put it through my g function machine, and it's going to come out as 1 yard. So the output of the first function, here's my output of my first function, is becoming the input of my second. So let's go down to the bottom here. Let's go down to the bottom here, the last example. And we're going to look at our composite functions first, so that you can understand what the process is. So first of all, I'm going to rewrite this as g square bracket f of, and what is f of 2? It would normally be an x, but I want to know what the composite function when x is equal to 2. Okay, so the first thing I'm going to do is figure out what f of 2 is. So I want to know what is my function value, my f function value, when x is equal to 2. So look back at your f function. Here's my f function. When x is equal to 2, what's my function value? Negative 3. When x is 2, f of 2 is going to be negative 3. So for f of 2, I'm going to put in negative 3. Now I want to take my g function, find out what my g function is when its x is negative 3. Okay, the next one, I'm going to rewrite it. This is f of what? G of negative 1. Start on the inside. Find the value of your g function when x is equal to negative 1. And then we're going to plug that value into our f function. Okay, here we have a composite function of our f's. So this is the composite of f of 1. So you're going to find the value of your f function when x is 1, which is 2. Good. And then you want to find the value of your f function when x is 2, negative 3. Remember, we're getting values of x. We're finding out our value of our f function, and then we're taking that value and putting it into our g function, or in the last case, back into our f function. Okay, now we're going to go back. Okay, so domain of a composite function. First thing we're going to do is we're going to find the composite function. Then we're going to determine the domain of the composite function before simplification. Then we're going to simplify, and then we're going to determine the domain after simplification. So we're going to be doing several steps here. These examples will probably be done better on another sheet of paper. And the first thing that we're asked to do is find f of g of x. And again, it would be helpful for you to rewrite this as f square bracket g of x. So this is saying that I'm going to take my g of x function and I'm going to put it into my f function. So g of x is this expression here, the square root. So it might be helpful for you then to rewrite this as f of what g of x is equal to. So in my f function, I'm going to put this expression wherever I have an x. So I'm going to put the square root of x plus 4 into my f function wherever I have an x. Okay, the square root of x plus 4 squared is x plus 4. Then I have minus 4. And I have the square root of x plus 4. And then I have minus 1. Okay, don't make the common algebraic error of taking 4 minus 4. Do not do that. Order of operations says that this 4 is being multiplied times the radical, so it cannot be subtracted before it gets multiplied. The only terms you can combine are your 4 and the negative 1. So we're going to put these two guys together. So we have x plus 3 minus 4 square root of x plus 4. Next part says determine the domain of what we just did. So determine the domain of f of g of x. Well, to figure out the domain, we want to look at the function before we simplified. So we're going to look at this function right here. And what restrictions do we have on the domain for that function? The radical, good then, the radical. Remember, radical functions. So we have a square root in there. What do we know about what happens underneath? Can't be less than 0. So whatever we have underneath the radical has to be greater than or equal to 0. So that means that x is going to have to be greater than or equal to -4. Looking at my function after I simplify, what's going to be my restrictions on this one? Well, I still have the same radical, don't I? So the restrictions are going to be the same. So then my domain is right here. So writing that in interval notation, -4 to infinity, including -k. Part C, it says find g of f of x. So now I'm going to take g and I'm going to put f of x into it. So again, it might be helpful for you to write this as g of, and then put in your f of x function, x squared minus 4x minus 1. So this means I'm going to take this function and put it into my g function where I have an x. So this expression is going to be put in for x in my g function. G of f of x is going to equal the square root of x squared minus 4x minus 1. That's the x part, plus 4. Go ahead and simplify. You should get x squared minus 4x plus 3. Okay, so that's part C. That's the simplified version. Part D, it says find the domain. So if I looked at my pre-simplified version and my simplified version, they're the same. Nothing's changed other than the fact that I combined my constants. I didn't add any more x's or anything like that. So how do I figure out my domain? Okay, you're on the right track. How do we find our domain up here? There we go. So that should be your first step. Take your quadratic and get greater than or equal to 0. How do I figure this out? I need to find what? Factor. What are my factors going to be? X minus 3 times x minus 1. Now what do I do? Set them equal to 0? We could set each of them equal to 0, okay. So what is this giving me? It's giving me the zeros of the function. It's giving me my x-intercepts. So we can either use a sign chart, or if we're really good with remembering what kind of equation or a graph would this be? Parabola. Or if we're good at knowing our parabolas, we can go ahead and put our zeros on here. So that's 1. This is 3. Is this a parabola that opens up or down? So that means I have to go through these zeros and I have to go up. So my domain is where this is greater than or equal to 0. So okay, negative infinity to 1. Okay, is that including 1 or not? So where is my function greater than 0? Wherever it's above the x-axis. If you wanted to do a sign diagram, you could. We're given the function f of x equals 2 over x plus 1. And the first step says we need to simplify, find and simplifying. Should be an and in there. F of x. So rewriting that with my square brackets, it's going to become f square bracket f of x square bracket. Makes sense to everyone so far? Okay, and what's f of x? It's this expression right here. So we're going to take this expression, 2 over x plus 1, and we're going to put it into our f function wherever we have an x. So I'm going to draw a little line here. So we're going to take this guy right here, and we're going to put him back into the function where there's an x. So now we're going to have 2 over x plus 1 plus 1. Sure, you've seen this before. What's this kind of fraction called? Anybody remember? Complex fraction. Yep, fraction within a fraction. So I want to simplify. How do I simplify? There's a couple ways. There's 2 ways. I could get a common denominator. Okay, so that's finding a common denominator. That's not necessarily the easiest way. So that's one way. The other way is to multiply by the LCD for your entire fraction. So what is the LCD for my entire fraction? Looking at the denominator, what would my LCD be? X plus 1. Just looking at the denominator. If I wanted to look for a common denominator in the bottom, what's my common denominator going to be? Okay, x plus 1. Now looking at the numerator, remember 2 can be rewritten as 2 over 1. So what's my common denominator upstairs? 1. So using 1 times x plus 1 gives me a common denominator of x plus 1. So I'm going to take my numerator and I'm going to multiply it by my LCD, which you told me was x plus 1. And I'm going to take my denominator and I'm going to multiply it by x plus 1. So looking at my complex fraction, do you see where I'm multiplying both the numerator and the denominator by the same expression? So I'm multiplying my complex fraction by, in essence, by what? 1. X plus 1 over x plus 1 is 1. So I haven't changed my fraction. When you do this, make sure that you multiply in the numerator. I think that would be, you'll do that one okay. So 2 times x plus 1. Down below, make sure that you multiply each of your terms by x plus 1. So make sure you multiply x plus 1 times 2 over x plus 1. And make sure you multiply x plus 1 times 1. So you're multiplying every single term in your complex fraction by your LCD. That's the goal. So in the numerator, we should have 2 times x plus 1. In the denominator, we're going to end up with 2 plus, simplifying, numerator, 2 times x plus 1 over x plus 3. Okay, it says determine the domain. So to determine the domain, we have to look at the unsimplified version first. So looking at my unsimplified version first, what do I know is not allowed? -1, because if I have -1, my fraction is undefined, not 0, undefined. Okay, so I know that x is cannot be equal to -1, because then 2 over x plus 1 would be undefined. Now looking at my simplified version. Looking at my simplified, Lily, what do I know about my simplified version? My denominator cannot be 0, so therefore I know that x cannot be equal to -3. So x can't equal -1, or I wouldn't have a fraction to begin with, and it can't equal -3 because I wouldn't have one at the end. So then in interval notation, we're going to have -infinity to -3, and union with -3 to -1, and union with -1 to infinity. Make sure you always read from left to right. So we have the function f of x equals 6 over x minus 2, and we have g of x is equal to 3 over 5x. And the first part asks us to find f of g of x. So rewriting, you're going to end up with f square bracket g of x. Then put in what we have for g of x, which is 3 over 5x. Then I'm going to put this expression into my f function where I have an x. So I'm going to take this expression right here, and I'm going to put it into my f function where I have an x. So this is my unsimplified version right now. What can you tell me about this function? What values of x are not allowed? 0. So x cannot equal 0. You might want to write yourself a little note. Okay, then we need to simplify it by LCD for this entire function. 5x. So I'm going to multiply 6 times 5x. I'm going to multiply 3 over 5x by 5x. And I'm going to multiply 2 by 5x. God bless you. So make sure that you multiply every term by your LCD, which in this case is 5x. 5x's should cancel out. So 6 times 5x gives me 30x. And in the denominator, I'm going to have 3 minus 10x. So this is my simplified version. The denominator cannot be equal to 0. Does that sound familiar? It's a rational function. So x can't be equal to 0. X can be equal to 0. 3 minus 10x cannot be equal to 0. So therefore, x cannot be equal to 3/10. So part B, where it asks for the domain of my function, I need to take those two value answers that I got before, where x could not be equal to 0, and x could not be equal to 3/10. Did somebody say 3/10? Did I miss that? Oh, I didn't hear you say that, Erica. I'm sorry. And then remember to write your interval notation as you read from left to right. So it should be from -infinity to 0, in union with 0 to 3/10, in union with 3/10 to infinity.